Okay, everybody, in today's lesson, we're going to talk about interpreting data trends because in science, obviously, we're going to do lots of experiments and we want to be able to see how those variables that we're experimenting with are related to each other. We need to understand how that works and be able to communicate that very clearly. So when we talk about this, first of all, in lab investigations, we usually control one variable and measure the effect it has on another variable while you hold all other factors constant. So we're changing one thing, we're seeing how does that affect something else, and we're trying to control for everything else. So for example, you might vary the force on a cart and measure its acceleration while you keep the mass of the cart constant. After the data are collected, you then make a graph of acceleration versus force using the techniques for good graphing. All right, and the graph gives you a better understanding of the relationship between the two variables. So being able to take data, put it into a graph, and then look at that graph and see how those things are related is going to be incredibly important to us in science. And there's 3 or 4 very common relationships in physics that you should be able to identify and know. All right, so you should be able to get used to seeing these and be able to identify them. So I want to talk about that. So the first one is a linear relationship. So linear is known as directly proportional, okay? So if we were to graph the data, when we graph it, we get a straight line function that looks something like this, okay? And this is going to happen when the variable on the horizontal axis changes by some factor, and then the variable on the vertical axis changes by the same factor, all right? So you change one, the other changes by the same factor. So if I double the variable on the x-axis, the variable on the y-axis also doubles. If I triple the variable on the x-axis, the variable on the y-axis also triples. So a non-physics example might be how much money you spend on gas versus the number of gallons you buy. Imagine on the vertical axis, we put the total money spent on gas, and on the horizontal axis, we put how many gallons of gas you buy. Obviously, the more gas you buy, the more money you're going to spend, but those two things grow in direct proportion to each other. If I buy twice as much gas, I'm going to spend twice as much money. Not all relationships work this way, but this is probably the most common one. And if we look over here, we have a set of data that kind of mimics this. So you'll notice as we increase the forces, a great example would be if I go from 20 newtons to 40 newtons of force here. So that would be a doubling of the force. Notice what happens to the acceleration here. It went from 12.5 to 25. So it also doubled. When I doubled the force, I also doubled the acceleration. This would be a directly proportional relationship. The next important type of relationship we see in physics is called inversely proportional. And inversely proportional, in this situation, as the variable on the horizontal axis changes by a factor, the variable on the vertical axis changes by the reciprocal of that factor. All right, so as one changes, the other changes by the reciprocal of that factor. So for example, as x doubles, y changes by a factor of its reciprocal, which would be 1/2. If I were to take x and multiply it by 4 times, then y would change by 1/4. All right, so whatever happens to x, we flip it, and that's what's happening to y. All right, so a good example, just simple example, would be the amount of time it takes to paint a room versus the number of painters. All right, so imagine if I'm trying to paint this room, it's going to take a certain amount of time. If I get help and we have a second person working with me, theoretically, it should take half as much time. All right, so twice the number of people, half the amount of time. So you'll notice as x is increasing, you'll notice that y is actually decreasing. So this is curving down. This shape of this graph is called a hyperbola. Okay. And this is an example of a data set that kind of mimics this. All right, so you'll notice as x goes from 1 to 2, for example, y went from 80 to 40. So when we doubled x, we got half of y. All right, if we go from 1 to 3, we're tripling x. Going from 80 down to 27 is basically 1/3 of 80. All right, so that's what's happening here. All right, another relationship that we see a lot in physics is a quadratic relationship. All right, and a quadratic is a parabola. The shape of the graph is a parabola. So we see these types of things in algebra 2, sometimes in algebra 1, but it's in the family of functions we call polynomials. All right, so in a quadratic function, as the variable on the horizontal axis changes by a factor, the variable on the vertical axis changes by the square of that factor. So remember, square means multiply by itself. So if x were tripled, so 3 times x, y would increase by 9 times. And the reason for that is 3 squared is 9. So if I multiply x by 3 times, I have to multiply y by 3 squared times. That would be 9 times. Okay, so an example of something that does this is a falling object. Right? If I drop something and it falls for 1 second, it falls about 5 meters on Earth. A little bit less, but right around 5 meters. If I drop an object and I allow it to fall for 3 seconds, it falls 45 meters. All right, so it doesn't fall 3 times as far, it falls 9 times as far. And the reason why is because gravity is causing that object to accelerate, get faster and faster as it falls. So it's not going to fall the same distance every single second. All right, so the graph looks like a parabola like this, and a set of data that models it will be something like this. So notice if we go from x being 1 to x being 2, we're increasing x by a factor of 2. Notice what happens to y. Y increases by a factor of 4 here. 2 squared is 4. Or if we go from 1 to 3 on the x, we're tripling x. We're multiplying x by 3 times. Look what happens to y. Y went from 2 all the way up to 18. All right, so it's gone up by 9 times. And then the last one we see, probably not as often, but sometimes in physics, is a square root relationship. So in this situation, as the variable on the horizontal axis changes by a factor, the variable on the vertical axis changes by the square root of that factor. So here, as you go further along, the changes get smaller and smaller. The graph starts to flatten out, flatten out. It's kind of the opposite of what we saw with the quadratic. Okay, so if you had an object slowing down as it was moving, this would be a good example. Okay, so here in our data set, you'll notice as we go from 1 to 2, we've increased by doubling. We've also increased on the y-axis, but by less than 2 times. All right, if we go from 1 to 3, for example, we've gone up in the x column by 3 times, but on the y column, we've not even gone up 2 times. All right, so it's going up, you can see, by less and less and less as things change. So in this situation, as if one thing is increasing and the other is increasing by less and less and less, then it's possible that this could be a square root relationship. So that's where I would look for something like that. All right, so these are all good examples of types of relationships we see a lot in physics. Now, not everything that we study is going to fall into one of those 4 categories, but the majority of the things we look at this year in our physics class are going to be in one of those categories. So you want to be able to identify them, to look out for them based on the shape of the graph or based on the data set. We should be able to tell that's what's happening, and you should be able to communicate that when we do an experiment. You don't just want to say, oh, well, as you know, as the marble was moving for longer, it went farther. Right? That doesn't tell me a whole lot, right? Was it speeding up? Was it slowing down? How did it change over time? We want to be very specific about these sort of things. And by communicating a type of relationship, we can be very specific. And that's what we're trying to do.